So what we've actually been doing with the help of TTTech then is working on improving the core standard networking technologies, IEEE 802.1 Ethernet, to basically much more precisely deliver information in these standard networks. To basically guarantee the delivery of that information, guarantee the fact that it'll get from point A to point B, and in what kind of time frame.
Again, TSN is a very key enabling technology for this, because what you have now is you have communications that are going between each one of those virtually. So there's no longer necessarily a physical network cable and switch. It's virtually built into a lot of these. But think about the data pipeline that's going into and out of these compute boxes. You now suddenly have 4 or 5 or 6 or 10 or 12 applications here that are networked and trying to leverage the industrial internet and the Internet of Things and trying to feed data for analytics.
And the safety functionality that the deterministic Ethernet implementation, the way we're implementing it with TTTech, what that enables as well, it allows us a higher degree of control and safety features that we can add to our turbines without adding additional cost.
Automotive, industrial, same silicon. And TSN needs long-term dependable products. FPGAs are typically there for 20 years plus. Acceleration is key. If you want to address your power challenges, just going to the next process node is not the solution. You have to be smart on your system level how to accelerate your software. And they are flexible. You can implement whatever you want. Connectivity, safety, security. So this is just to give you an idea of how TSN could be broadly adopted today with the IPs which we have, and where we can really go together with you, the industry, into the next evolutions of TSN.
Ethernet means really a true shift in the design of the next generation in-vehicle network systems. So it truly can enable new features and functions. It will increase bandwidth. It can reduce cost and weight. It fulfills the automotive demand for extended temperature range and provides the robustness being required in the EMC field. And it also paves the ground for the quality being required. And then it enabled the next generation domain-based architectures, maybe even ideas of distributed architectures as presented, and can help to make security an integral part of the car's design.
We believe that we are moving now through virtualization to real scalable system where you virtually could use any ECU to process any sensor input. And Deterministic Ethernet provide the real-time performance and fault-tolerant features to achieve this. And this is why we are engaged on this technology.
We, as developers, we need deterministic Ethernet, because it's not only a matter of sending information from one source to the other. It's the way we work. In the ZFS, for example, it's a very complex ECU, and I have a lot of software parties, of people developing software. how do we manage that? How do we bring the people together? How do we find a way that if one makes a mistake or something is wrong in one software component, it does not enable the whole system. So what we do is we separate the influence of one software component to the other.
So we're pleased, we're very, very pleased and honored to be associated with both Audi and TTTech and working with them on this ZFast controller architecture. We believe this is for sure a game-changing multi-domain controller, game-changing for the industry. You know, the concentration of the computing power, the significant step function increase in the power of that, and then while also reducing complexity at the sensor level. So we're pulling you know, that smarts into a single controller.
So I think with our deterministic Ethernet and our integration approach, we can really bring together the requirements for a high level of safety, high performance, and an optimization in terms of using and leveraging all the advantage that we are getting with these complex SoCs, with these high-performance compute chips that we are getting. We can bring together fail operational mechanisms and communication in a coherent architecture. We can provide partitioning there to really speed up the development process and integration here. So we have all the features built in. We can do co-simulation on the PC, which is helping us deliver faster, and virtualization is coming as a next step.
Take with you that deterministic Ethernet is becoming real, that you can do time-scheduled networks now on standard-based IEEE standards, that AVnu is going to be the compliance test, that the automotive industry is starting to endorse it, and that many industrial players are getting interested.